Hi, this is chapter 8 and 9, which is on correlation. First of all, I want to show you some correlation graphs. On the left here, this is a perfect positive correlation, and this positive correlation has a value of 1, meaning that all the points are on the same exact line. And this would be a high positive correlation, where the correlation is 0.9, and so that means that it follows a line and the trend is upward, but it might not be on a perfect line like this one. So this is a high positive correlation of 0.9. At 0.5, positive correlation will be a low correlation. So the data is still trending upward, positive, but it's not so tight as these two correlation. And then this is a correlation of 0, which is no correlation, and the data is scattered rather randomly. On the other side of this is the negative correlation. So this would be a low negative correlation of negative 0.5. So the data is trending downwards, and it's not following an exact line, but at least there's still a downward trend. This would be a high negative correlation, which is has a value of negative 0.9, and it trend downwards and it follow fairly close to a line. And this would be a perfect negative correlation, which follows a line that goes downwards. And just to be clear, these numbers has nothing to do with the slope. It just tells you how strong the correlation is. And all these are called linear correlations. Correlation that follow a line. Okay, I want to just go over one computation, which is how to find the correlation coefficient if we're given a bunch of data points. So this is x, this is y. We can plot it as we saw earlier. We want to find how strongly is y correlate to x in a linear manner. So we have some values given to us already. Sometimes you might have to find these values, but you need to have the average x value, the average of all x's, meaning add them up, divided by 5 in this case. You need to also find the standard deviation of x, of all the x value. Again, this is done from chapter 4. And so we're given that the standard deviation for the x value is 2. The average for the y values, add them up, divided by 5, is 7. And the spread, or the standard deviation of y, has a value of 4. So we need those 4 values to calculate the correlation coefficient. If we don't have them, we need to calculate them. But sometimes the problem will give us these values. Okay, so I think that one way of doing this is actually to insert. So again, on your first exam, one option is actually to do all the problems on the Word document itself and then submit it as a Word document. And so I recommend using the Word document tools. For example, I'm going to insert a table here to kind of do this computation. Again, this is all from the textbook. So I'm going to do an insert. And if I want to say a table here, and I want to make this be maybe a 6 by, so I want 6 of these, 5 of those. So here we go. And then I'm going to copy this value down to this table. Now we'll copy this value down to this table. So I strongly recommend doing all your tests on Microsoft Word. Once you get used to it, it's a nice feature for writing math equation, and it makes things a lot easier when you submit the assignment rather than scanning it to PDF, writing on by hand, and then have to rescan it. So this is provide a nice way of doing this. Okay, so the way we do this is that we have all the x value, all the y value, and on this column would be we want the z-score for the x values. And so how do you find that? Well, one way of doing this is to take the x value, right, 1 minus the average 4, then divided by the SD. So in this case, we want 1 minus 4 divided by 2. And that is negative 1.5, which is negative 3 over 2, which is negative 1.5. We do the z-score for the next x value, which is 3. So 3 minus 4, which is, so again, here it is, I'll do this again, 3 minus 4 divided by the standard deviation. So again, this is x value 3, subtracting 4, which is the average of the x value, divided by the standard deviation, which is 2. And again, this is called the z-score, or sometimes the book will call it the standard units. This applies to the z-table normal distribution that we saw in the last assignment. This gives us a value of negative 1/2, which is negative 0.5. Again, this is 4 minus 4 divided by 2. 4 minus 4 divided by 2. That's going to be 0. We do the same thing for all of these. So for 5 minus 4 divided by 2 is 0.5. And then 7 minus 4 is 3 divided by 2 is 1.5. So these are all the z-scores for x. Here we do the same thing and find the z-score for y. And again, it's the same calculation, except we do it for the y value. 5 minus 4 divided by, actually it's 5 minus 7, because that's the average for the y values. Then divided by 4, because 4 is the standard deviations of the y value. So again, 5 minus the average divided by the standard deviation. And that's going to be negative 0.75. And then we do the same thing for the other values. 9 minus 7, which is 2, divided by 4 is 0.5. 7 minus 7 divided by 4 is 0. 1 minus 7 is negative 6, divided by 4 is negative 1.5. And then 13 minus 7 is 6, divided by 4 is positive 1.5. Again, you can check the work there, but it's just a simple z-score conversion. Then on this side, we want the products of these z-score. So in other words, we want to multiply this by this and put it here, and multiply this by this and put it there. So we do that. Let's use the calculator on here. Negative 1.5 times negative 0.75. So 0.75, and you have negative 1.125. So we can keep doing this. Negative 1.125. For this one, you multiply these, you get negative 0.25. For this one, the product is 0. For this one, the product is so it's 0.5 times negative 1.5. So that product is negative 0.75. And for this one, it's going to be 2.25. So again, that's 1.5 times 1.5. Actually, I just realized I made a mistake here. 5 minus 7 is negative 2. Divided by 4 is actually negative 0.5, not negative 0.75. So that means this is going to be, sorry about that, this is negative 1.5 times negative 0.5. So that's positive 0.75. There we go. So the last step for this is the correlation coefficient is found by taking the average of this final column here, the column of products. So in other words, you add all these and divide by 5. So one good thing about Microsoft Word is that you can use the equation editor. So if I go to Insert and do Equation, it can give you a nice way to enter equations. Up here, here's the Home, here's the Equation Tools. You can use all the symbol, less than or equal to, greater than or equal to, square root, etc. These are fractions, for example. You can use different kind of fractions. This is exponents, subscript, etc. These are all the roots. So really anything that you need And basically you only need basic fraction and some basic symbol over here, but using this can help you do your first exam and also the rest of your exams directly on the exam on Microsoft Word. So I recommend doing that. So I'll show you how to do it here. We're going to find the average of the last column here. And so I'm going to say fraction. And in the top box here, I'm going to have the sum 0.75 plus negative 0.25, sorry, plus negative 0.25 plus 0 plus negative 0.75 plus 2.25 divided by 5. Again, this is the average of all these numbers. And it turns out that if you add all these numbers and divide by 5, you can check on your calculator, but you get 0.40. And that is the correlation coefficient of this data set. So once again, a quick recap. This column right here is the z-score for the x value that requires you to take the x value, subtract the average, divide by the standard deviation. And this column is a z-score for the y values. Again, take the y value, subtract the average, divide by the standard deviation of the y value. And so that's that column. And then this column is the products of these z-scores. Z-score for x, z-score for y. So negative 1.5 times negative 0.5 is positive 0.75. So you multiply these numbers, you get that number, etc. Right? The product of these two columns give you that column. And then the last step is to take the average of the products. Add these together, add them together, divide by 5. There are 5 numbers. Notice, this is 0. You include that as a number, so it's not divided by 4, it's divided by 5. And once you do that, then that number, after all this calculation, is the correlation coefficient of this data set. So it says that there's a positive correlation, but not a strong one. Okay, great. Thanks.